Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. In this video, we discuss about application in geometry which covers about equation of the plane. This is the first part about equation of the plane. We are more focusing about the concept. So as I said earlier, we are focusing about to find the equation of the plane, okay, from the learning outcome. Right, so let's see the situation of this plane. Okay, the thin sheet here so represent a plane. So let A would be x1, y1, z1, a fixed point on the plane, right? So this one A, and then N, that is A, B, C. So this is N, right? So N will be a vector perpendicular to the plane, also called a normal vector. So that's why we use N notation, because N here represent normal. And then we also let R, X, Y, Z, it will be any point on the plane. Okay. So apart from A, so now we also have R. Okay. So next, so from there, it would be R and A, the position vector from the origin. Okay, so let's say this origin. So to point A will be position vector A. So to point R will be position vector R. And then we also know that since N is a normal vector to the plane, so AR, if we join the 2 point to be a vector AR, and N the normal to the plane, so AR, if we dot product with N, it would be 0. Okay, remember the properties of the scalar product, the dot product. So the dot product equals to 0 if these two are perpendicular, right? And then next we expand, AR will be OR minus OA dot I equals to 0. And then we also replace this one with R minus A dot N equals to 0. And then we expand. Remember the properties of scalar product, we can expand. So R dot N minus A dot I equals to 0. And then lastly, we bring A dot N to the right hand side, so will be R dot N equals A dot N. So this will be our equation of the plane. Okay. So if we have R, usually it refers to the vector equation of the plane. And we know we can replace R with xi, yj plus zk. Right? And also N will be ai plus bj plus ck. And then A will be xy, x1i, xy, y1j, and then z1k. And then from the vector equation of the plane, so we know here the equation earlier. So we replace R with this one. Okay. So we replace to here. And then A here. So from N, R dot N. And this one also A, and this one also N. Okay. So after we substitute together, and then we know after when we do the operation of the dot product, we can eliminate I, J, and K, right? So it will be AX plus BY plus ZZ equals to P. So what is P? So remember the previous slide, we already mentioned what is P, right? Okay. Okay, we also already put here. So P actually AX1 plus BY1 plus CZ1. So okay, we put together as a P, okay, because all of these are a constant. So straight away S equals to P. Right. So this form of the equation highlighted in the yellow here. So this is what we call the Cartesian equation. So remember the Cartesian equation, x, y, z. So ABC comes from the normal, and then P after we do the dot product A dot N. Okay. So later on when we discuss about the example, you will be more clearly about how we get this kind of Cartesian equation. Right. So before we discuss about the example in the next video, so I strongly suggest you to understand first, okay, to understand first about the various condition of the plane, and from each situation how will you find out the normal to the plane and also the position vector A. So N and A here is very important, so make sure for each cases you fully understand how we determine N and A. Right, so let's say the first one, the basic one. So the plane given a point and also a normal to the plane. So straight away we know N will be vector N and point A will be position vector A. Okay, this is very straightforward. Okay, usually we don't come across with this situation. The situation at least a bit difficult. Okay, this is very easy. Right, next the second situation, 3 points on the plane. So here we have 3 planes, A, B, and C. So we can choose which point we want to put first. If you want to put A first, you have to find out the vector AB and vector AC. If you want to choose point B, so you have to find out vector BA and vector BC. Remember, AB and BA is different, okay? The sign will be negative. That's the difference between AB and BA. So make sure you clearly how find out this vector. So remember, if you want to put A at first, so it should be vector AB and AC. If you want B at first, so it will be vector BA and BC, and so on for C. But usually we use the first one lah. So AB and AC. So usually if you choose vector AB and AC, so straight away point A will be our position vector A, okay, the component A in the equation, right? Right. So now look at the third situation here. So parallel to another plane. So as usual, we have a point on the plane. So this point will be our A. And then to find out A, so from the another plane, we should have N, right? So let's say N1. So this N1 is actually parallel to our N. So we can take this N as our N. Okay, settle. And then for the fourth situation, 2 points on the plane and perpendicular to another plane. So here the situation. So we have vector point A and point B. So let's say we find out vector AB, right? So firstly, we choose point A as our A. And then we find out vector AB. And then next, from another plane that's perpendicular with our plane. So let's say N1. So this N1, we have another vector, and if we do the cross product between N1 and our vector AB, then we will get our normal, that is N. Okay, so in short, to find out N, we have to do cross product between N from another plane and also the vector AB, that is we joining together the 2 points. So that would be our N. Then next, the fifth situation, 1 point on the plane and perpendicular to another 2 planes. So as usual, a point here would be our point A. And then from the first plane, we got N1. And then the second plane, we got N2. So these two normal, when we do cross product, we will get our own N. So our N will be the cross product between N1 and A2. Okay, clear? And then the sixth situation, we have a point on the plane as usual, a point, that will be our A. And then a perpendicular to a line. So this is our line. So let's say line L. So we know the equation of the line A plus TV. So we have V here. So this V here is parallel to the line. And coincidentally, this parallel to the line will be perpendicular with our plane. So it means that the V here is equivalent to our N. So we can use this V as our N. Okay. So that's the situation. And then the 7-1. So we have 2 points and parallel with a line. Okay. So we have 2 points. So as you know from the previous situation, we will join these two vectors and we get vector AB. And then from a line that is contained also on the plane, as I said earlier, the line we have A plus TV, that is V is parallel to the line. So we can take as another vector V here. So when this V, we cross product with our another line that is AB, then we can find out our vector parallel to the plane, that is N. So N would be the cross product between vector AB and the V from the line. Okay. And then to find out and then to choose position vector A, you can choose either point A and B. But as I said earlier, since we find out vector AB, so for surely we choose point A. Okay. So that's the 7 situation. So make sure you memorize all this situation, because in the next video we discuss an example and the question how we find out the equation of a plane regarding all this situation. Okay. So until then, thank you very much. Thanks for watching. Bye bye.